Let's talk about amplitude and period. For functions y equals a times sine of x and y equals a times cosine of x, the number of the absolute value of a is called the amplitude and is the largest value these functions attain. We can think of amplitude as their max and min height. It's the min height when we multiply by a -1. So we can, for example, look at y equals 2 times cosine of x and y equals 1/2 times cosine of x. In this example, the amplitude would be 2, and in this example, the amplitude would be 1/2. Now let's talk about period. Since the sine and cosine functions have period 2 pi, the functions y equal sine of kx, or k times x, the sine curve, and y equals cosine of k times x, the cosine curve, where k is some number greater than 0, complete one period when 0 is less than or equal to k times x, which is less than or equal to 2 pi. In other words, 0 is less than or equal to x, which is less than or equal to 2 pi over k, and their period is 2 pi over k. Example 5 wants us to graph y equals cosine of 2x. Now, before we graph this, I'm going to label my y-axis and my x-axis, and we know that 2x is going to be less than or equal to 0, which is going to be less than or equal to 2 pi. And then if I divide all sides by 2, then I get 0 is less than or equal to x, which is less than or equal to pi. So that means that our values for x are going to span from 0 to pi. So basically, it's being pushed in horizontally. So I'm going to go ahead and label my axes with some x and y values. All right, so I know that quickly I'm going to graph y equals cosine of x for reference, and I know that cosine of 0 is 1, and this -1 looks a little low, so I'm going to raise that a little bit. Okay, and cosine of pi over 2 is 0, cosine of pi is -1, cosine of 3 pi over 2 is 0, and then cosine of 2 pi is 1 again. So here I'm graphing our regular cosine graph, and then in green, I'm going to graph y equals cosine of 2x. And I know again that our domain is between 0 and pi for one period. So that means it's getting smushed in horizontally. So this is going to be 3 pi over 4, and this is going to be pi over 4, and it's going to look something like that. So again, the green graph is y equals cosine of 2x, and the black graph is y equals cosine of x for reference. Example 6 wants us to graph y equals cosine of 1/2 x. Now let's do the same thing where we take the inside of the parentheses and place that between 0 and 2 pi. Now if we multiply all sides by 2, we get 2 times 0 is less than or equal to 2 times 1/2 x, which is less than or equal to 2 times 2 pi, and that is going to simplify to 0 is less than or equal to x, which is less than or equal to 4 pi. So I'm going to go ahead and fill in and label our axes with some values. All right, so I went ahead and I filled in my x and y axis, and for reference, I'm going to graph the regular y equals cosine of x function in green. And that is going to look something like this. And then in pink, I will graph y equals cosine of 1/2 x. And that's going to start here. And basically all of the values, the x values, are being doubled. And so that results in a, that results in a horizontal stretch. I am on the struggle bus a little bit. Okay, third time's a charm. There we go. So the green is the original graph, and then the pink is the transformation graph. And again, notice that all of the input values are doubled, which leads to a horizontal stretch. Example 7 says find the equation of each graph, and part A says find the equation of the graph, assume the basic function is sine, and hopefully you notice here that the equations are already given to you, so this problem is done for us. We have sine of 2x, sine of x, and sine of x divided by 2 all graphed for us. So just take a look over this and make sure that you'd be able to come up with these on your own. And let's go ahead and move on to part B. All right, so part B says find the equation of the graph, assume the basic function is sine, and we're actually given some information here that is going to be very helpful for us. We know that the amplitude is 2, and we know that the period is 8 pi. Now, when we initially defined the period, we said that the period was equal to 2 pi over k. And recall that, the function might look something like y equals sine of k times x, like that. So since we're given the period here and we know that it's equal to 8 pi, I can plug it into that formula and I can solve for the k value in this equation. So if I cross multiply, let's say this is 8 pi over 1. If I cross multiply, then I would get 8 pi times k is equal to 2 pi. And then I can divide both sides by 8 pi. And these will divide out, and I get k equals, the pi's would divide out, and 2 divided by 8 is equivalent to 1 over 4. So in this equation here where I had k times x, I could have 1/4 times x, but we also need to utilize the fact that the amplitude is equal to 2, and that tells us that the number that we would multiply outside of the sine function is going to be 2. So that is the final answer for part B. Y equals 2 times sine of 1/4 times x. And if you wanted to condense that a little bit, you can also write that as x over 4 like that. And that is our final answer for part B.